Okay friends, we are going to start our next video regarding electrical protection scheme reading or understanding. So this is our second video. I'll try to complete within 10 to 15 minutes. Okay. So we know that in electrical circuits, wires will have some numberings and letters. These letters will have some meanings. That means you can understand by reading these numbers, even though if you don't have any drawings about the scheme, you can have overall idea of just reading those ferrules. So we will see what the letters mean for actually, and what are those numbers, and what actually you want to say. If suppose a wire has, or in a circuit diagram, a wire is mentioned with A and suffixed with some numbers, it means that CT circuit main protection. So main protection circuit, CT circuit will have a ferrule which start with A and numbers. Okay. So next, the letter B. So if in a wiring drawing, if there is a circuit mentioned with start with B and then suffixed with numbers, it means that it is a CT circuit which mentions about busbar protection. Then third one is C. C is a letters which fixed with some numbers to mention about the backup protection core or CT backup protection core. And then next one is D. D is meant for metering core of the CT or metering wiring in a control circuit. And then next E, the PT circuit. All the PT circuit will be mentioned by starting letter E. In a circuit drawing, the wire will be ferruled with starting with E. Then next one is F. F is nothing but feeder numbering. Suppose if you have a number of feeders, suppose I have 433 kV feeders, new identified feeders or new erected feeders, but I want to number them, then I can start with F1, F2, F3, F4. So F is for actually feeder identification. Okay, I'll zoom it so that we can see properly. Hope you are able to see it clearly. Okay. So now G. G is actually mean for synchronizing PT circuit. And then H. H is actually used to mention main AC supply or AC supply circuit. So if you have H, the ferrule start with H, or if it is mentioned any wirings which start with H and some numbers, then it denotes the AC circuit which is coming from ACDB or AC supply circuit. And I normally we don't use I anywhere, so we'll omit it I. And then the J. J is actually for the main DC circuit from DCDB. So incoming DC will be mentioned by will be denoted by J letter in the drawing, and also it will be ferruled. The wires will be ferruled using the letter J. Okay, these are the standard ferruling methods. Suppose if you want to trace out a circuit, then if you know these letters meanings, then you can rectify or you can find out the faults in a circuit very easily. So that's why they have given some meanings. So then K. K is all the control and protection DC circuits will have a letter K and started with some numbers. Then the letter L. Okay, L actually denotes indication or alarm circuit. So if you have any indication circuit or alarm circuit in a drawing, it will start with the letter L and suffixed with some numbers. And then next, the motor circuit. If you have a motor circuit, then the motor circuit wirings will have number M, and the ferrules also will have a M and suffixed with numbers. And then N. If you have a OLTC, or OLTC means on load tape changer or tape changer off load tape changer control circuit, there all the control circuit of OLTC will have a letter N. So if you see any wires any wires ferruled with N, or any drawings mentioning N, it means the drawing denotes to the drawing relates to the OLTC or tape changer control circuit. Now okay, O is not used anywhere. And then P. Here you have to see that P. So if you have a busbar panel or busbar circuit, RLBB circuit. This circuit will have control. This is control circuit, then DC wiring of bus bar circuit. I'm not talking about what do you say, CT circuit or AC circuit. It is only that bus bars, especially bus bar DC circuit, will have a ferrule P. You can see, I'll show you when we go to the when we are talking about, or when you look out to the scheme drawing, that time I'll show you that bus bar drawing also, and there you will come to know that this will be used for the DC circuits. This letter will be used for the DC circuits. So Q is not used. And RST, this is for identification of ROB, and some drawings they will use this S for SCADA wirings. So if you have automation system in your automation system in your substation, so those drawings or those wirings will have a letter will start with the letter S. Okay, then next one U. So U is actually used for potential free contact. We'll talk about this potential free contact. So this potential free contact, spare contacts, if you have any extra contact which is not wired with any control circuit or any other circuits, then these will be ferruled with U. So V and W not used, and H actually are not used, we have mentioned. And also somewhere for contact multiplication relay, it is suffixed with K, so that we will see below this. And another is Y phase indicators. Y, this is for phase indicators. Okay, now we come to know their letters and their meanings in a control wiring drawings or control wiring ferrules. So now these numbers, this sequence like 11, 31, 51, 71 actually used for phase identification. That means 1, 3, 5, 7. 1 is for R phase, 3 is for Y phase, and 5 is for B phase, and 7 is for neutral. For example, E11, E31, E51, E71. So, and then if we have a C11, A11, A31, A51, and A71, it means that this is a main protection circuit, and A11 denotes for R phase of the CT wiring, and A31 denotes Y phase of a main protection CT wire, and then what do you call it? A51 is used for main protection of B phase, and A71 is neutral wiring. So I have two. So I think you understand what I say. Positive and phase. Positive or phase. Suppose in a DC circuit, positives start with odd numbering, odd suffixing. Suppose J1 is positive, K1 is positive. And then even numbering is used actually for negative or neutral circuit. Neutral is actually for AC. Suppose we know that for AC circuit we use H as the letter. So for phase we use H1, that means odd numbering or suffixing. And neutral we use H2, that is even numbering or even suffixing for neutral circuit. So written circuit. So this is the general ferruling system. So for identification and easy for fault findings. So general, we can say is general form of ferruling or standard form of ferruling, so that you can identify easily. And drawings also will mention these letters in your control circuit drawings. Also you'll see these letter will see. So now we are going segregation or distribution of DC circuit in schemes. So we know that DC circuits in a panel or in a circuit breaker or in a panel, and DC circuits are segregated, they are not combined. That means they have separate MCBs for each and every circuits, so that the fault finding and reliability also increases. If once one of the circuit have a problem and other circuit will be in live. So suppose if main protection DC fails, then backup protection will be in service due to some problem, then we have a reliability increased. So, and this also have some general, standard numbering. That means for breaker control we used to have K1, K2. So closed and trip circuits will have a circuit identification K1, K2. If you are seeing K1, K2 in MCB, then it denotes breaker control circuit. So K1 will change, it will travel like K1, K3, K5, K7, K9, K11, so through the breaker control. So like that K2, K4, K6, it will travel to all over the circuits. So if you find K1 series or K1 K with suffixed this kind of number, then this is a breaker control circuit. So by seeing the ferrules or by seeing the number, the ferrule numbers and suffix and ferrule letters and suffix numbers, we can find which circuit it denotes. The second one is for main protection. So we know that main protection, differential, distance, and these are usually used as a main protection. So main protection have a ferruling like K101, 102. So if there is a circuit which start with K101 goes to K103, 105, 107, and 102, 104, 106, it means the circuit is belong to main protections. And then K201 the same, that it is belong to the backup protection. So if you find any ferrule with K201 series, then it is related to the backup protection. And K301, so it is for LBB or any other protection. If you have any other protections, that can be used to K301, 302 numbering. So if you see 301 or 302, so definitely you can have an idea that there is some other protection other than main protection and backup protection. So another, and then K50150, sorry, here there is a mistake. It is actually 502. So isolator control circuit. So we have isolators which can be controlled by mostly we have motorized isolators nowadays. So we should have some interlocks or control. For controlling them, we have a separate DC circuit. So that will have a K50150 ferrules. So if you see any K50150 ferrules, then it belongs to the isolator control circuit. Then again 6 KX1, KX2. It is actually for contact multiplication circuit. We have auxiliary contacts in isolators and circuit breakers. So if you want to use those contact multiplications contacts to be multiplied, then that circuit will be differentiated from other circuited by these ferrules. If you see any KX1, KX3, KX5, that it is connected to the auxiliary contacts of isolators or circuit breakers. Okay. Now L1 and L2, this is normally used for indication circuit. Definitely we'll have indications like CB on off, isolator on off, semaphores, another panel. So for identification of those, we use the ferrule with L with suffix 1 and 2. So if there is L101, 102, it denotes to the annunciation or alarm circuit. So we have an annunciation in our control panel or in our panel system. So if there is any fault, if there is any alarm condition occurs, so that circuit will have, so for annunciation purpose, the annunciation circuit will have a ferruling like 101, 102. We have a transformer, and it has a transformer will have 4 panels, like 2 control panels for HV side and 2 control panels, 2 relay panels, one for HV and one for LV. So for for identification of HV LV, we use actually 0 after these letters K01 and K02, or somewhere else. Suppose if you have a A11 as a A11, which is used for, that means E11 for PT circuit or phase of HV side, suppose 132 kV, 33 kV we have. Then if you put 5 or 0, 11 or 5, 11, or E1 11, so it means that E1 11, it means that it denotes to LV side of the transformer. Suppose if you have E11 for 132 degree side, and for 33 kV you can use E1 11 or E5 11. Some people use E5 11 and some use E1 11. So here I forgot to mention 0, 1 or 5s are used for transformers LV sides. Okay guys, can video for your basic scheme reading skills development. And if you know these letters, then only you can understand the drawings, scheme drawings. So suppose if I have a city drawings, and if I found this letter, and I should have in my mind, it denotes for the metering circuit of city. If I see this letter, so this main DC is coming from somewhere else and it is connected. And now, so this is the purpose of ferrule and meanings of ferrules, general meanings of ferrules, which I have mentioned here, and circuits segregation I have mentioned here. So you can have a look at these documents. I'll put these documents in what is called a description, so that you can download it and see for your reference. You can have it. Now what we're going to do is we are going to see another document. Okay, that is symbols. Okay, general symbols what we used to come across while seeing a drawing or while using a drawing. Okay, so these are basic electrical drawings. Hope you are able to see it. I'll look up. Yeah, I think, yeah, hope you are able to see it. So this is the basic electrical symbols. Resistors or will be shown using these letters, or this symbol or this symbol. Inductors are used, will be shown in the drawing like using this symbol. And capacitors and switch, push buttons, and then hooters or speakers, ammeters will be mentioned using this symbol, and voltmeters will be mentioned using this symbol. And then transformer like this, and relays, and then alternating current and light bulb, LED bulbs for indication purpose will be shown in a drawing like this, and frequency meter, watt meter. So this is general, basic electrical symbol and electronic symbols. Now we have resistors, different types of resistors. These are all, and you can have a look. And another thing is relay symbols, different kind of relays and their purposes all are mentioned here. So you can have a look. So it's an open contact, it's a closed contact. So it always will be open and it always will be closed. And this is normally open contact, normally closed contact. What does it mean by normally open contact, normally closed contact? We will see when we see the breaker drawing. Okay, at that time I'll explain you everything. And this is changeover contact. Changeover contact is nothing but 1 N 1 NC. It changes according to the condition changes. That means it has two contacts, one is NC and one N. It is common contact change its position when it gets supply from NC to NO. So that's why it's a changeover contact. And then okay, this you can have a look. I'll put it in the description so that you can download and have a look at this. Because if you have overall idea of this, then drawing reading will be very easy to you. And this is the different kind of mentioning the transformer or drawing the transformer in a drawing. So you can have a CT is mentioned. Okay, this is a transformer and it's actually potential transformer. CT, okay, this is current transformer mentioned here. So step down transformer, step up transformer. Definitely you have studied in your engineering, or you have seen these symbols somewhere else. But anyhow, just for reference or just for refresh, I have put this drawing, and you can go to this website also. You can have a look. But I'll definitely put these documents in the description so that you can download it. Next is capacitors and their different types of capacitors and their symbols are given. Okay, and inductors and their different symbols are given here. You can have a look at, because if you have an idea, then the drawing reading will be very easy to you. And then the fuses and circuit breaker symbols. Fuses will be like some people they use like this, and they use like this. The IEC system they use like this symbol, and NC and they use this kind of symbol. And so these are all the fuses and breakers, and what do you say, thermal switch. So these are we will see in a drawing when we go in detail to when we are going to see details about the schemes. So this just you can have a look. And here switches symbols, so how the switches and how they will be mentioned in a drawing. So here you can see limit switch will be mentioned like this, and what do you say, rotary switch closed, generic one, and then what do you say, rotary switch open. So these different kind of switches you have. You'll be come to see when I show you some drawings. And here the push buttons, how N1, NC, and push buttons open, push buttons closed, push button open, and okay. So these symbols will be used in our schematic drawing. So this is basic. So you have to have a look at this so that the drawing will be very easy to you to understand. So that's it. You enjoying or hope you understand my videos. If you have any doubt or if you have any issues or if you have any suggestion, you can write to me or you can comment on my video. And yeah, so this is for, and you have what do you say, next we will be looking at the drawings. So we'll be looking at a very simple 33 kV breaker drawings. Then we'll take any other transformer protection drawing or line protection drawing on 32 kV level or 33 kV level. Then further we'll move on, and I'll try to cover it all those drawings in a single video. Otherwise we'll make it as 2 videos. So anyhow, thanks for watching. Please do subscribe and also click bell button for our next videos. And thanks for your support. Have a nice day.